8.1, simplify, multiply, and divide rational equations. Let's go through this worksheet. Multiply, multiple choice. Identify all values of x for which this rational function is undefined, which just means where will this function not have a value, right? So to find undefined in a fraction, in a rational function, you just want the denominator equal to 0. Now the key thing here is that, well, let's just factor first. So let's look at this first one here, right? I need two things to multiply to get 12, but add to get negative 7. So that's going to be x minus 3, x minus 4. And then right here's the difference of two squares. I need two things to multiply to get, well, x minus 6, square root of 36 is 6 and negative 6. Different two squares. Now here's the key thing. When you want to find undefined, you do that before anything reduces. So I'm not going to reduce these yet. My undefined is before anything cancels out. So undefined is actually every single one of these. So it would be, in this case, it would be 3, 4, right? You're going to say each one of these equals 0. 6 and negative 6. So that would be j. J is where the values are undefined. So let's simplify each expression. So what we're going to do here is we're just going to factor this, especially the denominator. So if I factor that, I need two things to multiply to get negative 12, but add to get 1. So that'll be x plus 4 and minus 3. Plus 4 because the middle term is positive, so the bigger number is positive. Now I didn't ask for where's the undefined, but I'm going to do it anyway just to show you, right? If I ask for undefined, I'm going to do it before I reduce anything. So it's going to be at negative 4 and at 3, wherever the number would be 0. So that's where it's undefined, and then now I can simplify the problem. The x minus 3 is reduced, and I'm left with x plus 6 over x minus 4. Now some people try to cancel out these x's. That's not the way you want to do that. Remember, this x minus 4, just like this x plus 6, is actually in parentheses. We just don't write it most of the times. So these are like together. These are binomials. So I cannot cancel the monomial out with the binomial. So you just gotta leave it like this. They have to be exactly the same so they cancel. So that'd be my answer. Binomials would be exactly the same so you cancel. And now let's move on to the next one. Let's factor the top before I do anything. So I need two things to multiply to get 2, but add to get 3. Well, that's just going to be 2 and 1. So I get y squared, y plus 2, y plus 1, over 2y, y minus 4, y plus 2. Just like that. If I was going to do undefined, it would be, to separate it, right before I cancel it now, it would be negative 2, positive 4. And then here, 2y equals 0, divide by 2, you just get 0. There's nothing, so this would be 0, 4, and negative 2. Right, if I did that one, divide by 2, 0. So if I know I didn't ask for it, but if I was doing undefined, it would be at x equals 0, 4, and negative 2. Anyway, from now on, we just simplify. So the y plus 2's cancel. Now I can reduce these two because these are both monomals, so I just have to reduce them. So this has 2 y's on top, 1 y on the bottom, so this cancels with this. There's a 1 left over, so I just get y plus 1, 2, y minus 4. Next one. So this is, I won't worry about the undefined values because it's not asking for it. So we'll just simplify this one. Now I gotta factor this. Now the top here, they're both difference of two squares. Notice how they're both squares, and there's a minus sign. That's the difference of two squares. So I get x minus 3, x plus 3. Over here I get x minus z, x plus z. And then look what reduces. These, and we're left with x plus 3, x minus z, and 4. And that is it. Can't do anything else. 17. Let's factor the bottom. So I need two things to multiply to get negative 20. That would be 4 and 5. And it would be a positive 5 because the middle number is positive, so the bigger number gets the positive. So x plus 5 and x minus 4 is the negative 20, so there'll be different signs. We'll do the top the way it is. Now we can reduce. These cancel. Here, nothing, so I can't do anything here, but here they're both monomals, right? There's 2x on top, 1 on the bottom, so just reduce that. We're left with x plus 2, 6, x plus 5. Let's move on. So next we gotta factor both the top and bottom for once. Now the bottom looks a little trickier, so let's focus on top first. I need two things to multiply to get negative 14, but I have to get negative 5. That's like 2 and 7, and 7 would be negative because the middle number is negative. So I get this. Now this bottom, we're going to solve it the same way, but just keep in mind the 28's in front. So we're going to have the numbers, the constants in front, and then we're going to have the variable in the back. So two things that multiply to get 28, but add to get 3. So to me, negative 28, because they be different signs. So it'll be 4 and 3. It's 4 and 7. 4 and 3. 4 and 7. To be like this. Now the tricky thing here is the signs. Where do I put the signs? Now remember, I want, when the middle number is positive, I want 7 to be positive. So what does 7 get multiplied by? It gets multiplied by the 4 to get 28. It also gets multiplied by this x. So I need this one to be positive, because that'll give me a positive 7x. Like if I did it like this. Right, and then these two get multiplied. So I need this one to be negative. So I get the 3x I need. So this is it's factored. Now if you notice, nothing actually reduces. So let me rewrite it real quick. X minus 7, x plus 2 over 7 minus x, 4 plus x. 4 plus x is the same thing as x plus 4, because you're just adding, so it doesn't matter. But nothing reduces. So what we have here is these two are so close. If you remember from the notes video, all we have to do is factor out a negative. So we could factor out a negative. Remember, when you pull out a negative, all you're doing is dividing by negative. So this makes this negative 7 and plus x, or if we rearrange it, x minus 7. Like that. And then the rest of it's still the same. I can write this as x plus 4. It's all the same. These two reduce, and I get x plus 2 over negative 1 x plus 4. That's about as far as I can reduce that. Okay, let's move on to the next one. We're probably going to have something similar. So x minus 4 is good. I have to reduce this. Two things that multiply to get 48, but I had to get 2, so negative 48. So close together. So 6 and 8. So x plus 8, x minus 6. So there we go. This is the difference in two squares, but notice that 6 is in front, so that makes it 6 minus x and 6 plus x. And right here I need two things that multiply to get negative 32, but I have to get 4, so 8 and 4. So x plus 8, because again, notice how the middle term is positive, and x minus 4. Then we can reduce. X plus 8 cancels. Should have been a plus 6. And that's it. Now, right here though, notice these x's again. Again, there's like a sign off, right? There's a different drop of the sign, so I can factor out negative. So I'll do it off with this one to show you. So it'll be negative 1. And then that becomes a negative x and a plus 6. So we can write that as 6 minus x. And then on the bottom we have 6 minus x, x plus 6, x minus 4. These reduce, and you just have a negative 1 over x plus 6, x minus 4. And that is the answer. Again, if I wanted restrictions, or where it's undefined, it'll just be right before you reduce anything. So it'll be 6, negative 8, and 4. It's always before you reduce. Now we're going to multiply. So over here, so I generally like to keep this, the way I like to do is keep the numbers and the variables separate. So like the variables are easy, you just kind of count them up. So we'll do the variables kind of right here. Like before I even count anything else, this is a little easier just to combine it all. So how many x's do I have? I have 1, 2. 2 x's, x squared. I do have a w, so I'll put that over here first. And then I have 3 y's and 4 z's. Like that. And on the bottom I have 6 w's. I have only 2 x's. I have 4 y's and 2 z's. Right, so that and that. So those are the variables. And we'll reduce this down a bit. Now the numbers, right here you could cross reduce or just reduce on top. Like 14 and 12 reduce. I could divide them both by 2, so I get 7 and remember you can reduce top and bottom, 6. Anything else reduce? So I got 7 and 21 reduce. I can also go here 7 and 21 to make it a little easier. So because top, you go diagonally or up and down. You just can't go across, right? So top and bottom you can reduce. So 7 over 21, 7 goes 21 3 times. I think that's it. That's all I could do. I have a 1, a 7, a 6, and a 3. Nothing reduces because nothing reduces. So if we multiply across, you get 7 and 18. Alright, so now I'm almost done. I just got to reduce the variables. Remember, the variables, the easiest thing to do is just kind of look at who wins the tug of war. So my W's here, I have 6 W's on the bottom, 1 on top. So the bottom has 5 more. So if I reduce these, you're gonna have 5 on the bottom. The X's are equal, so they cancel each other out. The Y's, I have 1 more on the bottom. So it'll be 1 Y on the bottom. And the Z's, I have 2 more on top. So it'll be Z squared on top. And that's my answer. Next one. So I have this right here. I'm going to do the same idea. So with the variables, I'm going to simplify them. I'm going to rewrite them first. Just total them up. It's a lot easier. Whoops. So I have on top, I have a to the 6, b squared, and c squared. On the bottom, I have a squared, b cubed, and c. Right, just going across from the numbers. Just simplify the numbers on top. Variables are numbers are a little easier to do just by reducing. So like 15, 21, you could divide them both by 3. So this would be 5 and 7. They're gonna have a 7 and a 14. Again, you can always reduce top and bottom. 7 and 14, I divide by 7. So 1, 2. And then 2 and 6 reduce if you want to do that. Divide them both by 2. 1 and 3. If you want, you can just multiply them all and then reduce it. It's a lot easier to cross reduce first and then multiply across. And if I multiply across, I get 5/3. And then simplify that. Again, I think to me this is the easiest part. You just go, okay, which one has more? So I have 5 and 3. Then you go with A, which one has more? Top has 4 more. 8, 4. B's, bottom, B has 1 more. And the C's, the top has 1 more. Right? All everything else reduces. So just go, which one has more? Dividing is a lot like multiplying, but you just gotta flip this side first. That's the only difference, right? Is flip. Then you just multiply it. So let's do that. 9x squared yz over 5z4 times 50xy4z squared over 12x4y squared. Right, so once you flip it, now you can just multiply. We're gonna just do the same thing we've been doing. So I'm gonna do the variables first. I think the variables are slightly just simplify across. X squared times x is x cubed. I have y5 and z3. On the bottom, I have what? X4, y squared. That was easy. X4, y squared, z4. And then the numbers. Ooh, let's reduce this first. So 5 and 50 I can reduce. 1 and 10. 10 and 12 reduce. Because again, you can always reduce top and bottom. Diagonal or up and down, doesn't matter. So I can divide them both by 2 and I get 5 and 6. And I can actually reduce a little bit more. That's 6 reduces to 9 divided by 3. So this would be 2 and 3. If you multiply that across, I'm left with 3 times 5 is 15. And the 2 on the bottom. Right, then it's got to reduce the variables. And this is about which side has more. So I'm going to 15, 2. My x's, bottom wins by 1. My y, the top, wins by 2. And my z, the bottom, wins by 1. So this is a 2, it's hard to see. There we go. And that'd be the answer. Remember, for variables, it's always just who wins. Next one. 26 is just straight multiplication, so we're just going to do it again. Because apparently we love these problems. Let's say I have a w. I have x squared, y cubed. Did we just do this problem? Yeah, over here. So I'm going to skip this one. Sorry about that. We did it right here. It's hard. I thought it looked like 6 when I was making the problem. So that one we could skip. We've done that already. Let's get down to over here. Last couple. So here, back to like how we did on the first page, we got to multiply these. So now, again, same idea. Just factor both of these, and then we just cancels out. So over here, factor the top. So that's going to be y plus 3, y plus 5. Over here, right, factor the top. That's y minus, what is that? 2 things multiplied to get 18, but add to get 9. 10 and 1, what am I thinking? 2 and 9, not it. 3 and 6, that's embarrassing. Took me way too long to figure that out. And then the bottom here's the 2 squares. Alright, so up here, factor the top, then you have to be the same sign, so 3 and 6. Factor the bottom here, y minus 3. So that part you have to factoring done. That's the hardest part of this problem, because now you just reduce. Remember, anything top and bottom can reduce, like here, y minus 3 reduces. y plus 3 reduces, and y minus 6 y plus y minus 6 reduces. Alright, let's do this so to show how they connect. So we get that, and look what's left over, just the y plus 5. If we want it undefined, I know I didn't ask for it, but if we did, remember it's always the thing before you reduce it. So here, what makes this 0? 6 does. Over here, what makes that 0? 3. And then that'd be negative 3 over there. So remember, undefined or restrictions are always before you reduce. So whatever's set the number equal to 0 before you reduce. Anyway, next one. Same idea, we just gotta factor this. So this one's pretty simple. 2 things multiply, get 20, but I have to get 9. It's 4 and 5. The bottom one, a lot of people overthink this. Now, there's only 2 things here, and it's not difference of squares. What do they have in common is always the first question you should ask yourself. These have an 8 in common. Always factor the monomial first. Now you pull out the 8, and then it's divided by 8. Like over here, this top one. You're like, ooh, that's hard, but no, what do you do first? Do they have anything in common? These all have a 4. You factor out a 4 first. And if you divide them all by 4, you get this. And then you might go, wait, can I factor out some more? Is there 2 things that multiply to get 4, but add to get 4? 2 does. So you get that. The bottom right here, you should notice by now the difference of 2 squares. So it's x minus 5, x plus 5. Again, if I was doing undefined, it would be at negative 2, 5, and negative 5. But after you do all this, factoring is by far the hardest part of this problem. You just reduce things. So remember, anything on top of 1 can reduce. Doesn't matter side, left or right, doesn't matter. Like here, x plus 5 and x plus 5. And then x plus 2 reduces to one of these x plus 2's, doesn't matter. And then the 4 and the 8 can reduce. But I'll say that to after. Let's simplify a little bit more, because we did all the big ones. So I have 4, x plus 2, x plus 4, over 8, x minus 5. Then I can reduce the 4 and 8, they both divide by 4. So my answer would be x plus 2, x plus 4, over 2 times x minus 5. There we go. Last one. So this is the divide. So first thing I do is, like always, is flip this. So I'm going to get 3a squared plus 6a plus 3 over a squared minus 3a minus 10 times a squared minus 4 over 12a squared minus 12. Right, and then now it's the factoring free-for-all. So this first one here, it looks complicated, but remember, always look, see if they have anything in common first. These all have a 3. So it's actually just a squared plus 2a plus 1. And that does factor. It's a plus 1 times a plus 1. So I'm going to write it here because I'm going to have space over there. Alright, a plus 1 times a plus 1. 2 things that multiply to get 1, but I had to get 2, 1, and 1. So there we go. The bottom here, I need 2 things that multiply to get negative 10, but I had to get 3. That should be a minus 5 and a plus 2. Remember, the bigger number keeps the sign of the middle one, so that's the 5 should be negative. Times, on top here, difference of squares. They're both squares, so a minus 2, a plus 2. They're both squares, and it's a negative in the middle. And then down here, remember the first thing we look for? They have a monomial in common. You can divide the 12 out first. So 12, a squared minus 1. Remember, when you factor, you just divide. And then this is the different 2 squares. A minus 1, a plus 1. And then, so again, if I was doing restrictions, it would just be 2, 5, sorry, negative 2, 1, and negative 1. But other than that, how do you reduce? Just whatever cancels out top and bottom. First one I noticed is a plus 1. So a plus 1 and a plus 1. And then let's see, a plus 2. A plus 2, a plus 2. And I think that's it for the binomials. I think that's the only thing that cancels out. The numbers do reduce though. 3 and 12, I can divide them both by 3 and I get 1 and 4. And that's it. So I get a plus 1, a minus 2, over 4, a minus 5, a minus 1. And there you go. That's the worksheet.